Let me do an alternate way to do the limit that we did in the previous problem. So if this factoring thing kind of confused you, and you were like wondering, is there another way that we can try to do this problem? Well, there is another way that you can probably think about, and it's more of a Calc 1 and less algebra type. I mean, there's still algebra in it, but it's more of a Calc 1 thing. So basically what you want to be able to do is divide by the highest power of the denominator. And now if you look here, n to the 7th seems to be it. But notice how there's a cubed root there. So the highest power is going to be the cubed root of n to the 7th power. Okay, if I were to kind of rewrite this as a rational exponent, you're going to have n to the 7 over 3. So basically what you're going to do is you're going to divide by this n over 7 to over 3 to every single term. Okay, so this guy, I'm going to, the top part, I'm going to divide it by 7 over 3. And this bottom part, I'm also going to divide it by 7 over 3. So you have to be very careful with the denominator especially. So what you're going to do, you're going to take the limit as n goes to infinity. So this 4n to the 7 over 3, you're going to divide it by n 7 over 3. This guy, I'm also going to take n to the 4 over 3 and 7 over 3. This whole thing, this cubed root of n to the 7 plus n to the 3rd is going to be divided by n 7 over 3 as well. You have to be very careful because you're not going to divide it inside of it cannot enter the cubed root, not yet at least. Okay, so we're going to have the limit as n goes to infinity. This guy's going to cancel each other out, so I'm left with 4 plus n to the 4 over 3 divided by n to the 7 over 3. So that's going to give me 1 over n, I believe. Yeah, 1 over n. Okay, because then now it's going to give me negative 3 over 3. Okay. And then divided by, now this guy cannot enter the cubed root unless it has a cubed root. So I'm going to rewrite it a little bit. So we're going to have the cubed root of n to the 7th plus n to the 3rd divided by, I'm going to rewrite this as the cubed root of n to the 7th. So that way it looks a little bit better. Okay, now that it's the cubed root, now we can go ahead and enter. So it's going to be the limit as n goes to infinity of 4 plus 1 over n divided by the cubed root. Now I can go ahead and divide it. And it's going to be n to the 7 over n to the 7 plus n to the 3rd over n to the 7. So I'm going to be left with the limit as n goes to infinity of 4 plus 1 over n divided by the cubed root of 1 plus 1 over n to the 4th power. Now I can apply the limit because what's going to happen is that this guy's going to go to 0, this guy's going to go to 0, and you're going to be left with 4 over 1. Okay, which in this case will be the answer. So this is just an alternative way on how to do the previous limit, especially if you were wondering what exactly happened here. Okay, so right before I leave this as is, let me just do one more last problem on the limit comparison test to just make sure that we really understand this. So here's one last example, and we want to determine if this converges or diverges. So we're going to look at the sum from n goes from 1 to infinity of 2n squared plus 3n divided by the square root of 5 plus n to the 5th power. So you can go ahead and try it out if you want to. I'm going to go ahead and do it now. So what we're going to use the limit comparison test. So using the limit comparison test, okay, we are going to compare this a sub n. So a sub n is equal to 2n squared plus 3n divided by the square root of 5 plus n to the 5th power. And I'm going to compare it with a b sub n, okay? And the b sub n that I want to compare it is the highest power on the top, so 2n squared, and the highest power on the bottom, which is going to be the square root of n to the 5th. Okay, so it's going to give me 2n squared divided by n to the 5 halves. It's going to give me 2 over n to the 1 half. Okay, and obviously this thing by p series diverges by p series, because you can see that the value of p is 1 half, which is less than 1. So this diverges. So if I can show that the limit goes to some number, then we can show that this thing is also going to diverge. Okay. If not, then we don't know. Okay. So what we're going to start doing is we're going to go ahead and start out with the limit. The limit as n goes to infinity of a sub n over b sub n. Okay. So you're going to have the limit as n goes to infinity of this big term 2n squared plus 3n divided by the square root of 5 plus n to the 5th power times 1 over b sub n. So 1 over b sub n is going to be 2 over n to the 1/2. Okay, so let me write this as the limit as n goes to infinity, 2n squared plus 3n divided by the square root of 5 plus n squared times, let me flip that around, n to the 1/2 divided by 2. Okay, so this is going to be, give me the limit as n goes to infinity. On the bottom part, I'm just going to put the 2 on the outside, and square root of 5 plus n squared. I'm going to distribute this n to the 1/2 to both of these terms. Okay, and what I'm going to be left with is 2n to the 5/2 plus 3n to the 3/2. Okay. Now at this point, what you can do is you can either factor out the highest power, or you can divide by the highest power of the denominator. Okay, so that's what I'm going to do. So let me just take the denominator. And in this case, it's going to be square root of, wait a minute, there should be a 5. There should be a 5 here, and there should be a 5 here. Okay, now what I'm going to do is I'm going to divide it by the highest power of the denominator, so it'll be the square root of n to the 5th power, because it's n to the 5th power and you have a square root here. Okay, so I can write it as n to the 5 over 2. So every single term is going to get an n to the power of 5 over 2. It's going to be the limit as n goes to infinity of 2 n 5 over 2. You're going to get an n 5 over 2 plus 3n to the 3/2 divided by n to the 5 over 2 divided by 2 square root of 5 plus n to the 5th divided by n to the 5 over 2. So on the top, I'm going to have the limit as n goes to infinity. I'm just going to get a 2 on the top. This, when I subtract it over, what is that going to give me? -1, so it's going to be 3 over n. This needs to get inside of the square root, so I'm going to rewrite the n to the 5/2 as square root of n to the 5th. So this equals the limit as n goes to infinity of 2 plus 3 over n divided by 2, and then in this whole square root, you're going to have 5 over n to the 5th plus n to the 5th over n to the 5th. So now let me simplify this. So limit as n goes to infinity of 2 plus 3 to the 3 over n divided by 2 square root of 5 over n to the 5th plus 1. Okay, now let me take the limit. So this guy's going to go to 0. This guy is also going to go to 0. You're just going to have the limit as n goes to infinity of 2 on the top, 2 on the bottom, and then the square root of 1 on the inside, which in this case is going to just give me 1. 1 is a positive number that's finite. So this limit exists as positive and is finite. So by the limited comparison test, because we know that this guy diverges, by the limit comparison test, the sum from n goes from 1 to infinity of 2n squared plus 3n divided by the square root of 5 plus n to the 5th diverges. Okay.